Okay, so we're going to go ahead and talk about some extra logarithm properties that will expand our understanding so that we can actually do more complex problems. The first logarithm property tells us if we have an argument multiplied together, you can actually split that argument up and do log base b of just x and then add it to log base b of y. What this is essentially doing is actually using the exponential property of like b to the x times b to the y equals b to the x plus y. Because remember, logs are giving us exponents. So we're adding those exponents together to get an argument. So we're using that same property. It might be also easier to see an example. So if I had like log base 2 of 32, that's the same thing as 5. Well, log base 2 of 30, and that's because 2 to the 5th is 32, just as a reminder. Well, 32 is the same thing as 4 times 8. So I could, according to this property, split it up as log base 2 of 4 plus log base 2 of 8. And according to the property, that should give me the exact same answer. Well, log base 2 of 4, 2 squared is 4, so this is just 2. 2 cubed is 8, so log base 2 of 8 is 3. And 2 plus 3 gives us the 5 we were supposed to get. So that was not really a proof, but it showed an example. You can do a proof of this with a general base, but it's using just those exponential rules. So same idea, using kind of a similar exponential rule, we can go ahead and say that when we divide the argument, it's the same thing as subtracting the two logs. So you have log base b of x minus log base b of y. Now number 3 uses essentially the same idea as number 1, because if you think about it, anything to the, or x to the nth is the same thing as multiplying x together n times, which according to the rule number 1 means I could write log base b of x and add that together n times as well, which is the same thing as just doing n times log base b of x, because there's n of them. So those are the 3 properties we're going to use. One direction, expanding means you're going to have more, condensing means you're going down. So these are the condensed versions over here, and then these ones over here are the expanded versions. Okay, so we're going to start out with expanding. So remember, keep those 3 rules in mind. So right now we've got division, so I'm going to have log base 4 of x as one of them. Then I subtract, since 16 is on the denominator, log base 4 of 16. One of the last things you always do is you actually do evaluate any logs that don't have variables if they come out as integers. So I don't want decimals or anything like that. Well, log base 4 of 16 is 2, since 4 squared is 16. So our answer would be log base 4 of x minus 2. Let's do another expansion, because they'll get a little more complicated than that. So for this one, we've got essentially 2 different variables. So we're going to have 2 logs. We've got log base 7 of x to the, I wrote the wrong number, x to the 5th. And then since there's multiplication between, we're going to add these. So plus log base 7 of y to the 2nd power. And then those exponents in front, the last part of the expansion, if you recall step 3 right here, is exponents move to the front. So we'll do the same thing here. We'll move exponents to the front. So I have 5 times log base 7 of x plus 2 times log base 7 of y. And both of those have variables, so it doesn't expand anymore, and that's my answer. Let's do a few more. So once again, we've got multiplication in between e and x squared. So e will go in its own log, and x squared will go in its own log. And we're using natural log, so we have natural log of e, and it's plus natural log of x squared. Once again, the step 3 is the last one I always go to. If you see an exponent, always move it in front. So if we go back to this one, we've got an exponent on the x. So I'll move that up front. So I've got natural log of e plus 2 natural log of x. Sometimes I make that a cursive L because they kind of look like ones. And then if there's any log that doesn't have a variable, and remember e is not a variable, that's an actual number, then we simplify it. Remember, natural log is base e, so this is natural log of base e of e, which simplifies down to just 1. So we have 1 plus 2 natural log of x. Let's get even more complicated. So this next one really shows like a pretty full depth of what this is going to look like. So every constant needs to go in its own log, as well as each variable. So we've got the 6, we've got the x squared, we've got the y, we've got the w cubed, and we've got the z to the 4th. So all 4 of those are actually going to go in their own log. Sorry, 5. All 5 of those. So we have log base 3 of 6, so that's 1. Sometimes it's helpful to put them in parentheses just so you don't get confused. Then we got plus log base 3 of x squared plus log base 3 of y. Now, the w cubed and the z are both on the denominator, and so when it's on the denominator, you actually subtract. So we've got log base 3 of w cubed, and so is the z to the 4th, so I'm going to subtract my last one as well, log base 3 of z to the 4th. So notice I subtracted both of those. That's really important because they were both on the denominator. Anything in the numerator is always added. And then we go from there. So we've got log base 3 of 6. And what I mean go with from there, remember exponents. I should use a different highlight. Exponents should go in the front. So those get moved. So I'll move all of those. So we've got log base 3 of 6 plus 2 log base 3 of x plus log base 3 of y minus 3 log base 3 of w minus 4 log base 3 of z. And then last but not least, you always check logs that don't have variables to see if you can easily simplify them into integers. So you're just asking yourself 3 to what power gives me 6. That's not going to be an integer answer. So I'll go ahead and just leave this as is.